So in the second topic, which is about the molecules in covalent bond. So when the bonds are formed between the non-metal, this type of bond is known as the covalent bond. And how you will identify non-metal, again using a staircase, you can identify the position of the non-metal. So on the right hand side of a periodic table, you will find non-metals. On the left hand side you will find metal. So this is all about when elements on all elements from this side they mix with each other, this result in a formation of a covalent bond. So normally group 4, 5, 6, 7 tend to form a covalent bond. Group 8 is unreactive, does not react, so it does not form a covalent bond. And how covalent bond is formed? So a covalent bond is formed by sharing of electrons between the non-metals. So when the non-metals share electron, they tend to form a covalent bond. So you have to keep in mind, according to the group they share, the number. If it is group 4 covalent, group 4 element, then it will share 4 electrons. If it is group 5, it will share 3 electrons. If it is group 6, non-metal, it will share 2 electrons. And it is group 7, if it is group 7, it will share 1 electron. Now how to show the structure? Example, if I say draw the structure of a covalent structure of group 8, because they have complete shell, so group 8 does not tend to react. Only group 4, 5, 6 and 7. So if the question is draw the covalent structure of, number 1 is example F2. This is the first example. So we have to draw a covalent structure of F2, fluorine. Now how to draw a covalent structure of fluorine? First, F2 means 2 fluorine. So first what we do, we will draw 2 fluorine. This is one and this is another. Is it clear? The first thing, because we have to draw the structure. So what you will do, you will of F2, so F2 means 2 fluorine. So we draw 2 fluorine atoms. Now you have to check the group, which group fluorine belongs to. So for that purpose you have to check the periodic table. So when you check the periodic table, which group fluorine belongs to? So it belongs to group 7. As it belongs to group 7, so it means it should share only 1 electron. So because it belongs to group 7, so it means share 1 electron. And when we draw the shared electron, so we should draw the shared electron between the atom. So if this fluorine, it will share 1 electron, like it will bring 1 electron. And another fluorine will also bring 1 electron. Because they can share 1. So each fluorine will share 1. This fluorine will bring 1. The other fluorine will also bring 1. And they will form a bond with each other. So we'll circle them. It means they shared a pair of electron or 1 electron from each fluorine joined together to form a bond. Now what happened to remaining electron? Because fluorine belongs to group 7, so 1 electron it's shared. What happened to remaining 6 electrons? Because total there are 7 electrons, so remaining 6 electrons will be unshared. And how to draw the unshared electron? So we'll draw on the remaining electron of this fluorine, we'll draw on the circle, and the remaining electron for the second fluorine, remaining 6 will be there because 1 is shared out of 7. So remaining 6 electron on the ring. So there is a share of electron between the two fluorine atoms, and this attraction or sharing of electron, what we call this bond? We call this covalent bond. Is it clear? The concept of the covalent bond, the bond which is formed by sharing of electron between the two non-metals according to their group number, an unshared electron will be there on the circle. Is it clear? This example of fluorine. Why we are putting them in the center? Because the one which we are putting them in the center, it means these are the shared electron. Like these electron belongs to both fluorine, the shared one. And unshared one does not belong, like the unshared one, these unshared one belongs to the first fluorine and the remaining unshared belongs to the second fluorine. But what we draw between them is to show that there is a share of electron between the two fluorine atoms. And as it belongs to group 7, so each fluorine will share one electron. Now we don't have to put on the other shell, we just have to put in between them to show that they are shared one. I'll give another example. If I say draw the structure of O2, oxygen. So first what we do, we'll draw 2 oxygen. Then we'll check the group number for oxygen. Oxygen, which group it belongs to? So it belongs to group 6. So if oxygen belongs to group 6, how many electron oxygen will share when you check the group 6 element? If it is group 6, it will share 2 electron. So each oxygen will share 2 electron. So example, this oxygen, like on the left hand side, oxygen bring 2 electron. I am representing by a cross. The other oxygen will also bring 2 electrons. Because if one is bringing 2, the other also bring 2 electrons. So these are the shared one. Now, if oxygen belongs to group 6, the total, it should have 6 electrons. 2 electrons are already shared by this oxygen. So how many are left? 4. So these 4 electrons will be there on the ring. Same thing, if this oxygen shared 2 electrons, so how many are unshared? The unshared will be 4. Is it clear? This is structure of oxygen. A covalent bond between the 2 oxygen atoms. And how we can also, there's also a simple way to represent this. A pair of electron can be represented by a single line because there is a pair of electron or 2 electrons are there. So we can represent by a single line between the 2 fluorine. But here we have 2 pairs between oxygen. So how we can represent? We can represent by two lines, because one pair of electron means a single line. So if there are two pairs of electron, it means double line. Or we can say it is a double covalent bond. Here it is a single covalent bond. Another example, this is just a representation. When there is a pair of electron, pair means two electrons. So when there is a pair of electron, we can symbolically represent this pair by a single line. So we have two fluorine, one fluorine and another fluorine, and how they are connected? They are connected by a pair of electrons, so we can represent by a single line between them. This is just a representation. When you check oxygen, there are two pairs, 1 and 2. So if two pairs are there, what we can do? We can represent by two lines. Another example, like if we want to draw the structure of nitrogen, which is N2. So nitrogen N2 means we will draw two nitrogen atoms. Then we'll check using a periodic table, we'll check the group number. Nitrogen belongs to group 5. So if it belongs to group 5, how many electron it will share? Nitrogen is group 5 element. So if it is group 5, it will share 3 electrons. So when we draw the structure, 1, 2 and 3. So these 3 electrons from one nitrogen and 3 electrons from another nitrogen. Then we'll complete the ring. In exam, you should use a compass to draw these circles. So this nitrogen used 3 electrons. So how many are left which will not share? Nitrogen belongs to group 5, so it is sharing 3 electrons. So how many unshared will be there? Out of 5, it shared 3. So 2 will remain. And same thing, 2 will remain on the other one. So this is a structure of nitrogen molecule. And symbolically, how we can represent? Because one pair represent by a single line, but there are 3 pairs, so we represent by 3 lines, which shows that there are 3 covalent bonds between the 2 nitrogen atoms. Is it clear, this example of nitrogen? But sometimes, like here in this example, we have the identical atoms, but if covalent molecule contain different atoms, then we will start sharing with the atom with, so we'll start sharing with the least number. What does it mean we start sharing with the least number? I'll give an example. draw the atom which share most electron in the center, and start sharing with the least number. I will give this as an example. Like, we want to draw the structure of carbon dioxide, CO2. We know carbon and oxygen both are non-metal. Carbon is a group 4 element. So how many it will share? So carbon belongs to group 4, so how many it will share? It will share 4 electrons. Then oxygen belongs to group 6. Oxygen belongs to group 6. So how many it will share as it belongs to group 6? So it will share 2 electrons. Now we have to draw 1 carbon and 2 oxygen. So which one should be drawn at the center? Because we have 3 atoms. So draw the atom which share the most electron in the center. So in this example, carbon should be there in the center and oxygen should be around it. So the carbon should be there in the center and oxygen atom is around it. Now, the second part, we will start sharing with the least number. So start sharing with the least number. Which is sharing the least? Oxygen is sharing the least. So we'll start with oxygen. So this oxygen shared 2 electrons. And this oxygen will also share 2 electrons. So if oxygen is sharing 2 electrons, carbon from that side can share only 2 electrons as well. So if this oxygen is sharing 2 electrons, carbon will share 2 electrons from that side. Same thing, if this oxygen is sharing 2 electrons, carbon will share 2 electrons from that side. So total number of electrons which are shared by each oxygen, that's 2. And total number of electrons which are shared by carbon, that's 4. How it is 4? 2 from one side and 2 from other side. Is it clear? So what we did, I'll repeat what we did. After drawing the atom which is sharing the most electrons, we draw in the center and then we start sharing. How to represent the sharing? We start with the least number. So least number is oxygen. So each oxygen will share 2 electrons. If this oxygen share 2 electrons, the other oxygen will also share 2 electrons with carbon. And what about carbon from that side? The carbon will, because if oxygen is sharing 2 electrons, carbon will also share 2 electrons from that side. So one side it is sharing 2 electrons and the other side it is sharing 2 electrons. So total number of electrons which the carbon is sharing, that total will be 4. Now we'll complete, make a circle. One circle is for oxygen, one circle is for the carbon, and one circle is for another oxygen. So we have carbon sharing 4 electron, oxygen sharing 2 electron. Then we will complete the structure to draw the unshared electron, because oxygen belongs to group 6. So 2 it is sharing and unshared will be 4. And 2 it is sharing, so unshared will be 4. And about the carbon, because the carbon belongs to group 4, so it is sharing all the 4 electron. So there is no unshared electron on the carbon. So this is the actual structure of carbon dioxide. Is it clear, the structure of carbon dioxide? Is it clear, this example? Another example of ionic compound, if we want to draw a structure of CCl4, carbon, if what if CO2 share 3? No, it is fixed, Abdullah. It cannot change because carbon belongs to group 4. So as it belongs to group 4, it will always share 4 electron. And oxygen belongs to group 6. So as oxygen belongs to group 6, it will always share 2 electron. So this will always remain the structure of carbon dioxide in terms of covalent. It won't change. Yeah, I am giving more examples. You will understand. So another example, if we have NCl3. So NCl3, we have nitrogen which belongs to group 5. So if nitrogen belongs to group 5, how many electron it will share? So as it belongs to group 5, it will share 3 electrons. Chlorine belongs to group 7. How many electrons it will share? It will share only 1 electron. Now, which one should be in the center? We have 1 nitrogen and 3 chlorine. So nitrogen should be in the center because it shared the most number, and chlorine will be around it. You can make up or down, it does not make difference to the structure. Now, we always start the sharing with the least number. So chlorine is sharing the least number, which is 1. So we start sharing with chlorine. If this chlorine share 1, each chlorine will share 1 with nitrogen. So what happened from that side, nitrogen total it can share 3, but that side with each chlorine it share 1 electron. So chlorine share 1, nitrogen share 1 from that side, but the total number of electron which the nitrogen is sharing, that total is 3. Then we'll draw the circle for each atom. There are 4 atoms, so we have to draw 4 circles. 1, 2, 3, and circle for nitrogen. That's the 4th one. Now we have to complete the structure for chlorine because chlorine shared 1. It belongs to group 7. So if out of 7 it shared 1, so unshared will be 6. So 1, 2, 3, 4, 5, 6. This chlorine also 1, 2, 3, 4, 5, 6. This chlorine as well 1, 2, 3, 4, 5, 6. And for nitrogen, it belongs to group 5. So out of 5, it shared 3. So unshared will be 2. So there are 2 unshared electron and there are 3 total shared electron. Yes, Abdullah?
Sir, can we put nitrogen at left or right? Why we will only put in the center?
Why we are putting it in the center? Because it is sharing the maximum number. I told you that the one which shared the maximum number should be in the center. In the beginning, because it is sharing the maximum number, so when it is sharing the maximum number, it should be in the center so it can bond with more atoms. So whenever two atoms are there, two or more atoms are there, always keep this rule in mind, that draw the atom which share the most electron in the center and then start sharing with the least number. Is it clear? The covalent structure of NCl3. Another example. If you want to draw the structure of CCl4, carbon and 4 chlorine atoms. Carbon belongs to group 4. So as it belongs to group 4, how many electron it will share? Carbon belongs to group 4. So it will share 4 electron. That's right. And chlorine belongs to, each chlorine belongs to group 7. So it will share 1 electron. So which one should be in the center, carbon or chlorine? Which atom should be there in the center, carbon or chlorine? So the carbon should be in the center. So carbon in the center, and I have 4 chlorine. So around the carbon I should draw 4 chlorine. 1, 2, 3 and 4. But when I start sharing, I will start sharing with the least number, that is chlorine. So this chlorine will share 1, this chlorine will also share 1, this chlorine will share 1 and this chlorine will share 1. And then I will draw, because if chlorine is carbon total, it will share 4, but I cannot draw all the 4 on one side. If chlorine is sharing 1, carbon will also share 1 electron from that side. Same thing, if chlorine is sharing 1, carbon will also share 1 electron from that side. If this chlorine share 1, carbon will share 1 electron from that side. Chlorine share 1, carbon share 1 electron from that. So carbon already shared 4 and chlorine shared 1. Now we draw the circle for each atom. Chlorine, chlorine, chlorine and chlorine. 4 chlorine, and then for carbon we have to draw. So this is for carbon. Now we have to draw the unshared electron. Carbon will not have any unshared because 4 are there, all 4 are shared. For chlorine group 7, so it shared 1, and how many unshared are there? 6 electrons are unshared. So how we draw 6 unshared electron? Element Abdullah cannot share 5. If you check the first slide, I mentioned the maximum number here. It can share 4, 3, 2 or 1. That's it. Cannot be 5. Because group 4, 5, 6 and 7 are the non-metal. So it cannot be 5. It can be 4, 3, 2 or 1. So unshared are 6 electrons. So we'll complete this structure and draw the 6 unshared electron on each chlorine. So this is a structure of example. If it is sharing 3, I gave you this example. The previous example, if you check, nitrogen belongs to group 5, so it was sharing 3. And chlorine belongs to group 7, so it was sharing 1. So one side chlorine bring 1, nitrogen shared 1. Chlorine bring 1, nitrogen shared 1. Chlorine bring 1, nitrogen shared 1. So each chlorine sharing 1, nitrogen sharing 1, and unshared 2 electrons are there on nitrogen. And now I am giving example of 4 shared electrons when the central one is sharing 4 electrons. Is it clear? This example. No, you cannot have CCl3 because the structure should be complete. That's why, like all the, I cannot have for all the formula, I cannot have like CCl2, I cannot have CCl, I cannot have CCl3, I will only have CCl4 because these are not the right, they will not make the complete structure. That's why all the possible structures are, like all the structures are not possible, only fixed or definite proportion the atoms are combined to form a specific compound. Is it clear the concept of the covalent bonding and structures? Yeah, you will not find example in which electrons are not there or more or less. It will be same number. Example, if you want to draw the structure of HCl, so hydrogen always share one. It is having one electron and it will always share that one electron. And chlorine belongs to group 7. So that will also share one electron. So when we draw HCl, there is hydrogen and chlorine. If hydrogen share one, chlorine will share one electron. And then we complete the structure. For hydrogen, there is no unshared, and for chlorine, there are 6 unshared will be there. 1, 2, 3, 4, 5, 6. So this is a structure of HCl. Is it clear? This is structure of HCl, hydrogen chloride. So the important thing is you should understand the group number, and using a group number, like if it is group 4, it will share 4 electrons. If it is group 5, it will share 3 electrons. If it is group 6, it will share 2 electrons. And if it is group 7, it will share 1 electron. So that is the important thing which you should remember to draw any covalent structure. So today we discuss ionic, some question related to ionic compound as well as drawing the covalent structure. In the next session, I will give more examples of covalent structures. Any question related to the class today? Any question or a doubt? So today we discuss how to draw different structure. Next session, I'll give more examples related to this topic.